Welcome to our talk and our presentation. We are from Toronto, Canada, and we are representing Scotiabank. And in this talk, we're going to talk about two products which we built over the last 18 months. And I would like to introduce my colleague and Director of Engineering, Michelle. Michelle led both product teams for both products, Chassis and AppFactory, and her strong technical expertise in microservices architecture and her leadership was critical to our success story. So Michelle's going to do the first part of the presentation. I'll do the second part. So without any further delay, I'll give it to Michelle.
Thank you. All right. Hi, everyone. You can hear me clearly, right? OK, great. So I'm very excited to be here and to share with you our journey on Chassis and AppFactory. So as I mentioned, these are the two products we created within Scotiabank, and they are intended to help the development teams to accelerate their cloud-native application development. So first of all, has everybody heard of Scotiabank? Show of hands. Yes, a few. OK. All right. So I'll start with the introduction of Scotiabank. So you get an idea of the environment we're working with. So Scotiabank is founded in 1832, so it's a 187-year-old bank. It's got about 97,000 employees and 25 million customers around the globe. So we have a total of, last year we have an 8.7 billion in net income, and there is like $3.3 billion in IT budget spent as well across the globe. So just like every other enterprise, right? Scotiabank is also going through its digital transformation journey. We wanted to modernize our applications, our services, and leverage the cloud offerings in order to improve and transform our customer experiences. There is one thing that's making Scotiabank a little bit unique. I don't know if anybody have heard of saying that Scotiabank is actually the largest international bank in Canada. So what does that mean? So Scotia, throughout acquisitions and mergers, it actually acquired a large footprint in South America, Central America, and some in Europe and Asia, a part of Asia as well. So actually, for last year, close to half of our revenue was generated by all the non-Canadian countries. So now when we talk about modernization, it's not just about the Canadian landscape. We have to think about modernizing as a whole internationally. And this also, of course, introduces additional complexity, right, in terms of different set type of integrations. And the technology that's being used, developer skill sets, always somewhat different between country to country. And of course, the regulatory and security requirements are always going to be different depending on each country. So as we go through our modernization journey, there's a lot of things we have to consider. So what is the solution to this problem, right? So PLATO is Scotiabank's solution to our modernization problem. PLATO stands for Platform Organization. It's a very young organization within Scotiabank. So we are from a platform organization. We were born in 2017, so merely 3 years old. So we're very young. That doesn't mean we don't have a lot of responsibilities. So we are the bank's cloud development platform. So our goal is really to enable Scotiabank's technology teams to develop cloud-based modern applications faster and more securely to accelerate that time to market for innovation and transform that customer experience. If you are in Spring One a couple years back, there was a talk on our entirely CI/CD pipeline. So we already have a pretty mature DevOps pipeline that allows a development team to bring their build and deploy into production very quickly. So what I wanted to focus to talk about today is another area of PLATO. It's also where my group falls under. It's called Banking as a Service. So Banking as a Service is a set of services being built on top of the PLATO cloud infrastructure and pipelines. So it's also part of our digital transformation strategy. So what it really means is just really making available a set of business capabilities, build them in a modern way, and making them available as a service via a well-defined API interface through both internal and external clients. So as a part of this journey, we have modernization as part of this journey. So as you know, a bank like Scotiabank, the bank is 187 years old. There's a lot of legacy. There's a lot of core knowledge that's reside on mainframes, right? The Java J2EE servers, all that good things over there. So how are we going to transform them to a modern application architecture? So this involves transforming things like traditional point-to-point integrations, right? The monolithic services or like ESB, enterprise service bus type of architecture, to a more distributed API-first microservice-driven architecture, and ultimately towards a true event-driven microservice architecture. So what is our challenge in this space? So microservice concept has been out there for quite some time. And even within Scotiabank, we have a lot of teams, they are building microservices. It's not new. But from the enterprise as a whole, we're still starting from that journey. So right now we have 600, 700 microservices, I think, around Scotiabank, but we're accelerating very fast. So the problem we're trying to solve is really how can we accelerate the service development of these APIs securely, and also ensures that we achieve that acceleration through our digital transformation. So what are some of the concerns we have to solve when we talk about microservice, right? So what are the things that make a microservice production grade? Right? These are the questions we're trying to answer. So with that, this is our team's mandate. So with those questions in mind, we decided that we wanted to deliver a set of self-serve tools and components that help the development teams to build production-grade microservices with accelerated velocity. So there's a couple things I want to point out in this. So first is our focus is on the application architecture, is within the application development. What I have noticed that through a lot of enterprises' cloud transformation modernization journey, we first put our effort on the infrastructure and the pipelines, right? So we needed to create a pipeline, and we need to be able to build and deploy fast onto the cloud, right? So the next thing that's coming is how do we write our applications? In order for us to really leverage the various cloud capabilities, we also need to make sure that our application is built in a cloud-native way, right? I mean, if you have a microservice that talks to a VM, a database on VM on-prem, there's no way you can scale it, even if you put it on the cloud. So the application architecture is very important, and is what our team's focus is at. So what are the cross-cutting concerns that we needed to create this microservice and make it production grade? So then that comes to the second point is production grade, right? So everybody can write a microservice. I'm sure everybody sitting here, you can write a microservice, and you go to do a sprint starter, create a REST template, and then there you go, have a microservice in like 1 minute. But that doesn't mean it's production grade, right? So how do you handle your configurations? How do you manage your keys? Do you have sensitive information in your microservice? And if so, what do you do with those informations? And how is your microservice integrating with the rest of the ecosystem? There is a lot of things that need to be considered when we consider a production-grade microservice, especially in the enterprise environment like a bank. There's a lot more security or regulatory requirements that also has to be addressed for this microservice to go into production. And these are the specific areas we wanted to look at, and these in order to accelerate the application development team to productivity. Then the last thing I wanted to point is that the self-servedness. So we want our tools to be self-serve. That means that we wanted to create extensive documentations, training materials, reference guides, so on and so forth, so that a developer could just go through our documentation page and they have everything that's enough for them to be able to use our tools, right? So we take a reference, we look at things like Spring.io or all of those open source frameworks, and we take learn from them and you created our documentation page from them. So next, I'll talk about some of the key design decisions we made at the beginning of our journey. Okay. So first thing is don't reinvent the wheel, right? So we do want to build our tools in-house because the specific concerns we're trying to address is specific to our environment, right? Each enterprise, it's a little bit different. So we do want to build it in-house, but we're also not crazy scientists. So we're not going to be building everything from scratch, right? So we took a decision to start with a mostly used, well-adopted programming languages such as Java. It's also most easy to find skilled developers for this language. We also took a decision to start from best practices and also well-known open source frameworks, right, such as Spring Boot and open APIs back. So we don't want to reinvent. So we wanted to leverage best practices out there. And then the second thing is ease of integration. If you think about an application within the enterprise like a bank, the current state or even the near future state, it's really all about different sorts of integration, right? So we are moving towards a true event-driven architecture and target state, but it's going to take time for us to get there. So integration currently plays a big part when we do application development inside an enterprise like us. We actually ran a survey with some of our project teams. So for this, we were asking, during your application development time, so how is your time spent? What are the pain points you're facing? And an answer we're getting is that to develop the actual business logic for these products is only about 25% of the development time. And the rest of the time is a lot on, figure out the processes, right? Figure out what to integration, how to integrate, what are the different 10 systems you have to integrate with, and the production readiness and so on and so forth. And within this 75% of time being spent, at least 25% is around integration. So if we could have solved this pain point, and if you just address this one really well, we could have saved every development team 25% of time in their product development. So the solution we are designing must be easily adoptable and abstract the integration pain points for our application developers. Okay. And then loose coupling is our next decision. I mean, loose coupling is a very important aspect, and as I'm sure you all know, especially in terms of microservice-driven architecture, your microservices needs to be loosely coupled, and it serves one single purpose function, right? And it should have its own data store, so on and so forth. So what we're saying here is not just the loose coupling of the service in terms of other services. We're also taking a look at the microservice code base and wanting to make sure there's loose coupling in the microservice code. So this means a separate concerns of the business logic of this microservice with all the other cross-cutting concerns that can be reusable and shared with other microservices. And this also means creating a microservice code lifecycle so that our microservice business logic is separated from its consumer logic and its backend. So the backend meaning the integrations. So this has a lot of advantage, especially in our environment. So as I mentioned, enterprise like us has a lot of legacy. So as much as we want, it's probably not possible for us to start from the true cloud-native 12-factor app microservice from day one. It just doesn't happen in a lot of projects, right? Like, for example, you may be creating a customer microservice. You could deploy it on cloud, but your data is still in the core system where you probably have to access it via some sort of SOAP calls. Right? Until that data gets modernized, right? Until we start to leverage Kafka's event streaming and put that data on Kafka, you will stay with that SOAP connector. But as soon as we modernize the data, this design allows you to update quickly to a different connector. So, for example, if we're doing a event sourcing, you could have your own data store and you just swap the SOAP connector to our GPA connector. But your business logic, because it's already decoupled, you don't have to touch that. So that's loosely coupling is a very key design decision. And in the deeper dive, Mon is going to be given later on our lifecycle and connector architecture. He will address this point a bit more. So the last one is control design. So we wanted our design to be standardized. So standardization and governance in terms of the application code as well, especially for the cross-cutting concerns. So as an enterprise like this, it's very easy for us to go from 0 microservices to 1,000 microservices in a very short time. And without any standardization in these cross-cutting concerns, it's very easy for every microservice to be implemented differently, and it greatly increases operational cost. Okay. So now let me introduce the two products. So I'll start with Chassis. Chassis is a set of reusable components to address cross-cutting concerns for Spring Boot microservices. So needless to say, it's Java-based. It's a set of jars. And we chose Spring Boot to build on top of Spring Boot because a lot of the nice features for Spring Boot, such as aspect-oriented programming, the annotation-based configurations approaches, they really fit nicely with our idea, our goal to develop a easily configurable and reusable set of cross-cutting concerns. So if you're wondering what the cross-cutting concerns are, just one more slide, we will get to that. Okay. So now we have Chassis. We didn't really stop there, right? So Chassis basically is really a set of libraries, right? So developers, it's self-serve. A developer can download that library and look at our documentation and use that. But what we have noticed is that the transformation is just not on the technology, right? There is also the people and the culture aspect of it. As complex as Scotia is, not everybody is very familiar with microservices, and not everybody is very familiar with Spring itself. Chassis being developed on top of Spring, not everybody is familiar with that, so there's a natural learning curve of that. So we ask ourselves, what can we do to accelerate even further? And that's where we come up with AppFactory. So AppFactory is a cloud-based UI tool that allows you to generate apps based on the Spring Boot stack. It actually, to be more precise, it takes an API-first approach. So it takes in a Scotia-compliant API spec and it uses Chassis to generate the service. So AppFactory uses Chassis. Now, the goal for AppFactory has three folds, right? So it has the standardization, governance, and accelerate of your development. Our goal is to generate up to 80% of the microservice code where the application developers can just focus on the business logic of the project. Now, there are companies out there, like that sells these kind of tools, actually. So we actually did look around. There are a couple companies, and there are a few tools like this, and they're intended for enterprise like us to accelerate application development. What's different from us is that all of these tools we have evaluated, they are all a black box. It's usually like a drag and drop or low code or like configuration-based approach. You click through some things, it gives you a runtime, and you take that runtime, just deploy it. That creates additional. That means that the solution is very proprietary, right? You do not get to see the implementation. And also it creates additional dependency on vendors and additional operational complexity down the road. So when we design AppFactory, it's a UI-based tool, but we also offer a CLI, which if you prefer command line, you can put your configuration that way. But the decision we took here is really to give you a chance to download the zip file. So basically, AppFactory gives you the code, not the runtime. So it gives the zip file to developers. Developers team, project team still own the code, right? So they will put in their business logic, and they will still build and test and run the code, right? So at the same time, they get a quick start, and at the same time, they also get to look at the designs and the best practices we have done in our code base, so they could improve the developer skill set as well. Okay. So I have one more slide. Okay. So he's getting. All right. So just one more slide, and then I'll get to you. All right. So I just wanted to talk about the benefits briefly. First benefit is the architecture and governance as code. So this is a very important concept for the enterprise, especially as we move from the traditional development to microservice development, right? So application architecture in general from enterprise is not governed. It has not been governed, and product teams usually just do anything. We don't have a lot of cross-cutting concerns that's being addressed. It's not governed because the traditional, if you look at the traditional governance process in a bank, we run like architecture review board and things like this. It's not going to work in the microservice-driven architecture world where we're developing very rapidly. We could develop tens of thousands of services, right? We cannot have a manual process. So introducing tools like Chassis and AppFactory helps the enterprise from a governance perspective, and it provides that governance architecture as code. So as soon as we know that our product team are using these tools, we know that are compliant and they follow the enterprise standards. Uniform design, it's also a great benefit for the enterprise. So our design is standardized, and we have, for example, error codes for error handling, which is also standardized, and it greatly reduces operational costs down the road. And then these ones are more for the project teams, right? So with these tools, from a project team's perspective, their productivity is more predictable because they don't have to worry about estimates all these integration pinpoints. You don't have to figure out what needs to be done to integrate all these other systems, and they will be able to create a more accurate estimate for their project logic. Accelerated application development also is really the main goal for us to help accelerate application development and achieve faster time to market. And the last thing is that we're building products, not projects. So PLATO Platform Organization as itself is a product organization within Scotiabank. So we build products, which means that our engineers are supporting the products from end to end. And whenever we do a release, we have everything we have documentations, training materials, and everything that's released together as a bundle to our customers. And we're also taking a customer-first approach. So I talked about the control design, right? So we have an idea of all the cross-cutting concerns we need to address, but our backlog feature when to deliver each components are based on our customers, right, based on our use cases. So all of these components are based on actual use case from our projects, and we do co-create some of these capabilities with our customers as well. Okay. All right. So with that, I will introduce Mon to the next technical capabilities of the product. So Mon is our chief product architect for Chassis and AppFactory. So he's created these products from ideas, design, and all the way into delivery. Okay, all right.
Okay, thank you.
All right, thank you.
Okay, thanks, Michelle. And now we'll do a bit of a deep dive into both products. We'll first go through Chassis, and then we'll go through AppFactory, and towards the end, we'll do a demo of AppFactory's UI. It's a wizard-based UI, so I'll show you how we generate an app. But let's first talk about Chassis. So what is Chassis? This is a question which was asked to us a lot within the bank. Scotiabank is in, I think dozens of countries across the world. Their teams literally in hundreds to thousands of teams which we don't even know about. And very often I'm in the elevator and people just ask me, what is Chassis? They know it's become quite popular in last 1 year. Thousands and thousands of developers are using it, but sometimes executives and marketing people and they ask you what is Chassis. But for developers, it's very simple. Think of it as a set of building blocks. Each building block is a reusable component for a capability that addresses cross-cutting concerns, such as logging, authentication, OAuth, data sanitization, error handling, connector architecture for connecting to backend systems like REST, SOAP, Kafka, JPA. So those are the cross-cutting concerns, which enable the developers and the implementation teams, those thousands of teams in the bank, to develop production-grade microservices, right? And that's the key. What is production-grade? So Chassis gives them the building blocks. 80% of the building blocks when they are creating their microservice, they can use those and only add their building blocks specific to their business logic. And as a result, they have an increased velocity. So that's what Chassis is. It's a set of building blocks or a set of components. It's a bunch of jars. Each jar represents a capability, right? Remember Michelle said architecture is code. You want authentication, OAuth, your team doesn't have to worry about it. We have written components which interface with different OAuth servers, different OAuth 2 flows, and we'll cover all the use cases for you. You want to do enhanced logging, please don't write your own appenders, your own format, nothing. It's available for you. We're giving you additional features. So let's go. What's a production grade application? Here I've shown a microservice, and you will see these green boxes are set of capabilities. You have security, which is authentication. You will have authorization, audit, dropping payloads of request and response into your logs, logging, distributed tracing, masking, which is data sanitization, caching the response of your backend orchestration, request vulnerability, OWASP, SQL injection, preventing malicious injection, code generation, that's AppFactory, PubSub connector to JPA, connector for REST, connector for SOAP, connector for Kafka, error handling, right? And then this team also did common.jar or core.jar, and that's common design library. They also wrote code for operation 1, operation 2, and operation 3, which were the 3 endpoints in their microservice. Think of that as account balance, account summary, and account transactions. So the team actually is responsible for building account domain microservice. But to make a production grade microservice, 80% of their time, months, they had to do all the other capabilities as well, right? This team doesn't exist. And that's the reality. Because of the constraints of time, budget, and resources, and the skills, this is the reality. Here they have done their operation 1, operation 2, operation 3, which is their business logic. But they didn't have time to do audit. They didn't care about creating a connector, common connector for talking to PubSub. They didn't care about code generation. Similarly, they did some kind of half implementation of SOAP connector, REST connector. They did a very good job in security auth. They did caching. They again have a common .jar, and they did error handling, right? So that's how they went to production. And that's the reality. And that's the reality across thousands of applications and more across the bank. So this is the landscapes. These are the 4 teams: Service ABC, DEF, UVW, XYZ, and banks full of these. Now all the monoliths are being broken, decomposed, and everybody's writing Spring Boot based microservices, and that's what these teams are. And you can see different colors. What we're representing is none of them are actually satisfying the criteria and include all the required capabilities which you need to make it a production grade. Someone has done logging, really good job. Pretty much all 4 of them have done logging. So you have 4 different logging implementations. They do need authentication, right? Someone's just done basic auth, someone's done OAuth, someone's done OAuth, but they are getting a JWT token, and from one layer they keep sending the same JWT token downstream. And even the components they all did, you could have thousands of different implementations of a given capability. And that's the reality. So this is a microservice without chassis. And that's how we started. When we started 18 months ago, we took a survey of the landscape of all the teams. We literally went and talked to teams, what are they doing? We looked at their code. And, again, they're doing some capabilities, and they're doing some capabilities not correctly. And some of the capabilities, they've just dropped it because they just didn't have time, resource, or skills. So that's what it looks like. What we have done is we have created a chassis product. So all those white boxes in blue landscape, that's chassis. And team only has to work on operation 1, operation 2, and operation 3. We will give them the connectors to talk to their providers. We will give them the design, how to have a uniform design, how to talk to communicate with their consumers, their providers. In the bank, about 80-90% landscape on the provider side is SOAP, REST, some kind of messaging as in PubSub, Kafka, JPA, and auth servers. We have written code, and it's in production for SOAP connector, REST connector, auth servers. And as I speak, we are going to release soon JPA connector, Kafka, and PubSub. Just with REST and SOAP, based on our survey, 80% of backend orchestration was covered. But by adding the other 3, it's close to 90 or more. And that's what we're going to do. If you want to have backend orchestration for JPA, we have a jar file for you. If you want to do it yourself, take our jar files for these connectors, write your code, simple 1 line of code, connector.connect, give it a request object, it'll give you this, response object, and your orchestration is done. These are the building blocks or capabilities which we have as part of chassis as of now. There are some capabilities being built, as I speak, and some we have for future. As you will see, they're all capabilities within the process. We did not focus first on capabilities which are outside the process, right? So for example, service discovery. All those Netflix, Spring Netflix ones, we did not create them because we know that landscape is changing fast. With Kubernetes, Istio, we didn't want to touch that. That landscape is changing a lot in the last 4 years and still not mature. But we are focusing on architecture and capabilities within the process. Every microservice needs some kind of standardized logging. You need to provide a very controlled way of how to do OAuth, following the spec, open specs of OAuth 2. You must have distributed tracing, trace ID, span ID. We have given them a simple, really, half a line of code of how to mask a field in any POJO. They can write an annotation. They can even write an annotation in a Swagger file, right? I want to mask my account number or social insurance number. I can just write, this is my mask this field and write in Swagger, and this is my strategy. Don't omit it, or here's a regex, or encrypt it, right? Error handling. We have given teams a common error handling design, and I'll talk about that. Lifecycle. This is key, and I have slides on that. This is that uniform design. We have given them a design for Java, how to write a microservice. We have defined key classes for them, key objects for them, layers and all those separation of concerns. We've done that. And we have kept it very light. We're not giving them a whole struts here. This is very light, but essential and complete. Caching. Again, we have given them one annotation. They use it. And we use Spring Cache and any cache provider like Redis, and it'll cache the response of a connector, backend system. Metrics. SOAP connector, REST connector, I talked about the connectors. Request vulnerability, we wrote code for different vulnerabilities we want to check, encoding, look for HTML, JavaScript, things like that, SQL injection and all that. Health check, we wrote special health check for backend for REST and SOAP. We are going to work on key obfuscation, so if a key is in the URL, what to do with that. We haven't done that. We have different vaults within Scotia, so it's going to get unified into one tool and one vendor, and at that time we're going to work on this. So now I'm going to go in some of the key ones. We don't have time to continue talk about each and every capability. I'm just doing a time check, so we're okay. Logging. Logging, very simple. What we want to do is we want to log to console, right? We want to use logback, SLF4j, nothing out of the ordinary. We want to use that. But we want to standardize it, and we want to give some enhancements to the developer. One of the big things we want to standardize and out of the box is, by default, it's async. Okay? It's async, and if a team needs to make it sync for some reason, they will have to go in their application YAML and say, I want to sync. But very soon, we did that because async was new when we did it for us. The code we wrote, it was in beta about a year ago. It's still, by default is there, but anytime we want, and we are planned to, we're going to make async as not only default, but mandatory. Other features, what we have done is we have used a builder pattern, and we've given them builder methods to assign a custom tag. So say you are writing an application where downloading some document. When you're logging it, just put a tag called downloading. So when the log actually goes to through your shipper to your log viewer, it's very easy to write your query there in your Splunk or Kibana or Grafana, saying that show me how many downloads have been done for other parameters, and so you have that thing. We have custom types and standard types we've defined. For example, we have a type of audit in addition to the levels, log levels, and I'll talk about those levels. Audit type is there. For example, we throw the request and response objects in the logs, but when we are doing that, we put a type of audit. So again, when you're looking at the viewer, if you just want to look at type audit logs, it'll just show you those. This is my request and response payload. We also added type called Lifecycle, which is our capability. If you put that show me the logs for Lifecycle, it will literally show you your sequence diagram. Because whenever we are doing those layers, which I'm going to talk about it, in the beginning of those layers, I'm saying I'm entering this layer, I'm exiting this layer, and this method and this. It'll actually show you your sequence diagram in the logs. So it's pretty powerful and very simple. One of the most important things people throw in logs are Java objects, right? We've given them a convenience method to do it very easily. Log exception, we've done that. So here's a sample code. Look at that builder pattern. If you want to log a Java object, you can do it at info level, e.with, this is the object, card list. I want to put some label. It could be, I could have said here card, list of cards, whatever you want. So in your log viewer, When you will expand this in JSON, it'll show cards. When you show it, the POJO will be there, and whatever message you want to do, right? If I want to add a tag to it, the last line, so you guys can see the mouse. I was talking about the lifecycle, and I can say I entered, my controller, right? Similarly, I can do that. Again, all the levels are at the top. You also have a type, a custom type. I talked about audit and everything. So this is it. It's a standard. On top of it, we have done standard format. It's JSON by default. If they want to use text, they will have to override, again, going in application YAML. So architecture as code, capability as code. Another thing we've done is that logging component is a starter. It's a Spring Boot starter. And how am I doing time-wise? I forgot to start the timer here. It's 12:11. So we're OK. Logging is a Spring Boot starter. You include this, you will get that functionality automatically. Tracing, distributed tracing was a separate starter as well. During this journey, we made this mandatory. If you get logging, you will automatically get tracing. Each and every log is going to automatically, by mandatory, going to have a trace ID and span ID. It uses Spring Boot 2's Brave, or if you're using Spring Boot 1, Sleuth. So we have used whatever Spring Boot brings. We're not going to reinvent the wheel, right? If your consumer is not sending you a trace ID, Chassis will create one. But guess what? Starting next quarter, we're going to start rejecting the calls which are coming to us, and if you don't come with the trace ID. And that's the power of Chassis is. We can control and enforce the governance, right? So that's what it is. As a result, every log, this is a screenshot from our log viewer, is going to have trace ID and span ID. I talked about masking. For example, you have account number, social number, any sensitive data, right? You want to mask it. The problem statement we're trying to solve here is we're trying to prevent the leakage of data in the log files. That's it, right? How does that happen? It happens through getters and toStrings. So what we have done is we used Lombok, and we have changed the behavior of getter methods. If you put an annotation of @mask on a POJO's property, we will automatically create an unmasked method, but the default getter will always give you a masked value. So you can say, this is at Swagger level. You can also start from a Swagger. So this is Swagger definition. As you can see, for account number, I'm saying x-masking and implement this strategy. Do not emit, right? If you want to do it at the Java level, you can say this. Account number is using a strategy of do not emit. Account number 2, truncate. Account number 3 is using a regex. So on the right-hand side, you'll see the result, right? Very powerful. Literally takes you seconds to do it. It took us a couple of months to build it, but now thousands of developers are using it every day, right? Lifecycle. It's a Java design. What I saw was that in the microservice world, over the last 3-4 years since Spring Boot started, application servers like WebSphere and WebLogic are gone. The concept of microservice was created. People have different definition and preconceived notions of what microservice is. The very reason they see the word micro, they think, oh, I can write all my code in controller. That's not right, right? Your use case is still the same. You still have to get the count balance, whether it was monolith, or it is a microservice, or it will go to a function where you're just doing a count balance. That was same in microservice too. It's just that they packaged the code together and they hosted it together in the same runtime on the same JVM and clustered it. Now, yes, you have partitioned it into separate jars, separate containers, but it's still the same code. So please don't write everything in controller, because the moment you do that, you have strongly coupled your backend orchestration code with your consumer code, right? And which is good for short term, but no project is just one term, right? It's not a project, it's a product. So if you're writing accounts, domain microservice account balance is not going to be done now. It'll keep on coming back with new features. The consumer could change. Right now it is a servlet-based consumer. It could be reactive consumer. It could be a Kafka consumer, right? Similarly, we're adding more connectors. So don't assume things won't change. But your business logic stays the same. You don't have to change that just because you have a different connector or a different consumer. So what we did was we looked at the separation of concern. Even in microservice, there are clearly 3 separation of concern. On the left side, you have to deal with everything to do with consumer. On the right side, everything to do with backend orchestration. In between, there is something called operation, which is about business logic. So 3 different layers for each separation of concern. Consumer was everything to do with consumer. Your request validation, anything in Swagger, all the endpoints, everything with consumer is right there in the Swagger spec, your open API spec. Business logic is your business logic, right? Connectors. Connectors and consumers never have to know about each other. It's completely decoupled, and that's what operation does, right? So this slide and the next one kind of goes into details what we do in which layer. So in consumer layer, if I go back to the previous one, we have 3 classes. There's a class for consumer, which is a controller. There's for each endpoint, there'll be an operation class. For each connector, there'll be a connector class. To provide the decoupling, we also have delegate layers for each 3 layers between them. Okay. So consumer layer consists of controller class and request delegate. Request delegate separates operation and consumer. What do you do here? Validation, gathering of all the data coming in from your consumer, packaging into a POJO, which we call consumer request, right? We have well-defined class, very simple POJO, which has the payload, right? It also has placeholder methods for important lifecycle events, because what else does consumer do? In the end, it has to prepare the response to send it back to your consumer, right? Your response entity and all that. So there's a placeholder method for that. And the code is generated if you're using request delegate. I talked about is using business delegate pattern. Operation layer, everything to do with business logic. This is where a developer is going to write their code. But what is it doing? It is responsible for all the orchestrations for backend, right? Say for a given use case account balance, I first have to go to one system. I have to go then validate or verify with another backend system, then do a recon or whatever. There may be 3-4 steps. That's what you do in orchestration. We have well-defined methods for different orchestrations. Right now we're doing in sequence. We're introducing parallel activities as well. You have to, for each backend call, create the connector request object. Whatever the connector wants based on their spec. So if it's a REST, they have a Swagger file too. And they have defined in that Swagger file that, okay, if my /accounts needs this input, we prepare that and we send it to them. Now, similarly, they also return for each endpoint, this is the data. So that's a connector response. Lifecycle code has well-defined methods and POJOs for each layer. It's very thin layer. If you see the generated code, it is very simple to understand. Just like Apple and Steve Jobs' philosophy that if you open the computer and if you generate our code and see our generated code, it's very clean and very simple. Connector layer, we created a connector architecture. What we did was, when you look at REST connector, yes, you can use REST template and its exchange method, but like we said, right? What about other capabilities? What about authentication? If one service is calling another service, yes, you have done REST template, but now the team has to write the OAuth code for that, right? What about caching? What about auditing? Automatically auditing of the request and response going for the backend orchestration. Distributed tracing. So what we have done is packaged all these 5 capabilities together, and we call that a connector. So an implementation team just has to get the connector bean and call its connect method, create the request class and manage the response class, and you're done, right? They want to take a look at the code. They'll quickly see that it's calling REST template and exchange method, but it's also doing those 5 things. So That's the power of connector. It's done, and that's governance, right? That's architecture as code right there. So if the ARB board has to know that, okay, how did you communicate with your backend REST thing? Did you use REST connector or not, right? If the team didn't do REST connector, then that ARB has to look more deeper. Otherwise, they'll be satisfied because they have already, reviewed our product and they know we're satisfied with that. So this is a sequence diagram of a microservice which is using chassis and lifecycle. Imagine thousands of services running in your production, and they all have the same sequence diagram with same naming convention. How easy the triage will be, the naming and the communication. If the problem happens and okay, I had a problem in prepare consumer response method, I've already gone to the back end and now it happened while coming back, right? So don't even worry about it. So finally, I'm going to talk about the last capability, and we're doing good with time. OAuth 2. We have 3 components within the OAuth 2 capability. First one is resource server. So we have created a starter. If you include that starter, automatically your microservice will become a resource server, right? It will do the token validation, token parsing. If your signature validation fails or expired, you reject the call. Scope-based authorization, standard Spring security annotation. You can use pre-authorize and add secured, and we'll do that. All you have to do is include that jar. That's about it. In your controller, you can use add authenticated principal, and you'll get the user object. If you want to use custom token claim in your jar, we have token converter classes to do that. So that's the resource server, right? Almost 80% of your applications will be resource server. That's all you have to do is go to your build.gradle, include this jar, and you get these 5 features. OAuth client, right? So OAuth 2 client, this is auth code flow. So think of a UI calling your first server-side layer. That's the auth code flow in OAuth 2. Here we have capabilities which will satisfy the OAuth 2 flow. Not only that, we have a specific auth server for this particular use case, and we will make sure that auth server is used and nobody can use a different one. The configuration, values for that auth server in different environments, dev, IST prod, all is given to you. Okay, service to service, most important. I talked about the REST connector, right? We put this thing in the REST connector. When you're going to call from one service A to service B, it will automatically go to the auth server, get the token, put it in the header, and send it. So it's done. All you have to do is use REST connector. AppFactory. What's an AppFactory? Quick time check. Okay, yeah, we're good. Cloud-hosted UI tool. It's a wizard. It has 3 steps to it. The first step is going to ask you for your Swagger file. The second step, you can look at all your endpoints in your application. That's what the screenshot is showing. This is a microservice which happens to have 8 endpoints in your Swagger. It's showing them. Some are white, some are gray. I'll show you why. We've added orchestrations in them. It's pretty slick UI, which we created. And within minutes, a developer is able to generate code. 80 to 90% of code is generated, included unit test. We are able to generate production grade code in a matter of days. And we did that many times. So let's do a demo. Before I do a demo, the use case for this demo is this. We're creating a cards microservice. Okay, there are 2 endpoints in it. So if you look at the Swagger of this, it'll have 2 endpoints. There is get cards, which gets you a list of cards. There is a get card, which gets you detail of a particular card, right? If you look at the business requirements document, which is what this table is representing, it's showing to us that the backend orchestration for getting the list of cards, there's only one. We need to call SOAP for that. The team which has built that WSDL has given us their spec, which is in a zip format, cards customer.zip. And it has WSDL and XSDs in it. And they've also told us that to get the list of cards in their SOAP service, they have an operation called custom query. Use that. Similarly, the second use case, get details of a card. It's a different zip file from a different team, different SOAP service, and they have told us there's an operation in the SOAP called debit card inquiry. So we're going to do that. I'm not going to do a live demo because I've learned in my previous presentations at the conferences, Murphy always comes and plays a joke with you. So what I've done is I've animated using screenshots. So I'm going to go do that. So bear with me. So you'll see 25-step process. It's pretty quick. So okay, there you go. Yeah. Can you? Oh, it's not coming. Oh, because I have to end the slideshow. Good. Okay, so this is the first page. You guys can see that, right? Fonts are not too small. Okay, so this is the first screen. First step, Michelle talked about. It's an API first approach. It's going to ask you upload your Swagger or OpenAPI spec file. You'll do that. In the left box where it says Spring Boot 2, we used to have Spring Boot 1. Again, governance, we took it out. We don't support Spring Boot 1. We don't want you to use Spring Boot 1. We just literally removed that option. Okay. So we click that button. It's going to say, okay, provide your Swagger file. We have cards no security YAML file. Literally within like sub-second response, it parses that Swagger and shows you two endpoints, get cards. It shows you both the methods are get, shows you URL, any description from Swagger is showing. Both of them are great. They're great because I have not done anything for these orchestrations. So I've only generated the code dealing with just consumer aspect, nothing to do with backend orchestration. I can go to the third step. So this step is add orchestration. I can decide, oh, I want to work only on this endpoint today, get card, not the other one. I can do backend orchestration, download my code, copy paste that code into my workspace in my IntelliJ on Eclipse and just do that. So let's do the get card, the right one. You see the three street light icons. I'm going to click that. Now it's going to ask you the spec of the target. Which backend service you're going to call. Is it a REST or is it a SOAP? Look at the drop down on the right hand side. Right? So say, we will change this to SOAP. And I'm going to click the upload button. That's the button I clicked. And now I'm going to use the spec, which is the zip file as per my document. I showed you the table, cards.zip, and it's showing that we have three different types of authentication available for SOAP connector: no auth, basic auth, and something called custom SOAP auth. I just picked basic auth. I'm going to put user ID and password, which they provided me. And again, it parsed all the WSDLs and XSDs and is showing me that particular service has that URL, which it took from the WSDL, and it has a service called card query service and two operations. Remember, they said use debit card inquiry. I'm going to click on that. And then there's this thing called enable cache. Do you want caching for this, right? I'll click on that. It will go through the XSDs and it'll show you your payload. Pick the key from one of those. I picked account type. I can decide how much expiry I want. There's a default value. Go. Look, that thing became white. And it's showing one orchestration. It's showing there's card query service and debit card query operation. Okay. Similar, let's do the other one now, the other endpoint. Again, target operation spec. I'll pick the other zip file. I'll change it to SOAP. I'll leave it no auth, a different service, different operations on the back end. I know I have to click customer query. I'll add. I don't want caching. I'll leave the URL. I'm not going to change, and I'm going to click done. Both the orchestrations are done. I can now click on the right arrow. Third page is just showing me in read-only view, what I've done. I can click the download button, and my zip file is created. Literally within minutes, you will have zip file. If you unzip that file, Because of copyright and all that, I cannot actually take you through the code, but I can at least show you the structure of the code. Remember the lifecycle we talked about? Source main Java, the package we gave on the first screen, cards is the name of the service. We have a consumer method, we have controller class, controller interface, request delegate class, which controller class calls request delegate class. Request delegate class will call the operation for both endpoints. Each endpoint has an operation class. For operation class, we have connectors then. Remember, we had 2 connectors we did during orchestration. So in the connector class, and look at the naming convention. It says get card C1. Get card is actually the name of the endpoint on the consumer side. So we have naming conventions. So the names may sound big to you right now, but actually, if you're the developer who did this, they will make sense. It's saying that for get card endpoint first orchestration, I'm calling card query service, which was in the WSDL, and the name of the operation was debit card query, and this is the SOAP connector class. Similarly, you have SOAP connector delegate class. So that's the AppFactory. I'll go back to the slideshow, presenter view. Do you want to come? So let's wrap it up. I'm going to talk about benefits. This is what Michelle talked about. Uniform design. Example was lifecycle, right? You cannot go more uniform than that, right? If you look at your code of all your applications, Dynatrace, you will see a similar sequence diagram, and that's powerful, right? Common error handling. We have written error handling design which all the teams flow. We have a defined unique error code structure, libraries for each component, how you should have controller advice. We've documented and everything on properly, uniform design. Governance as code. If one service is calling another service, if you use REST connector, you'll automatically use a particular auth server. And we will make sure you use client credential flow, right? And we will make sure that you cannot propagate the user jot, which was between UI and the first server side, and keep reusing and keep sending it. Every service will go and get its own token and do the token orchestration. So that's governance. Predictable velocity. An example was AML, anti-money laundering. We did a search microservice. We talked to the business analyst. Looked like a small service. Our prediction was, a week, production grade, ready to go to production. Our developer did that in 2.5 days. Yeah, right? It was done. Production grade with everything, ready for production. The business analyst next day came, changed the Swagger file. It took us literally an hour to entertain that request. Black Duck, they went through AppSec security. Black Duck flagged a couple of errors. We fixed those in chassis. Another 2 hours, we changed the chassis version, and there was. So look at the cumulative effect, right? That was predictable productivity. If this team did not have chassis, they would really have to think how many meetings they would have to talk about what kind of authentication I need, which team I need to talk to, right? Where is their Confluence page, right? And that's just one capability. We have 20 capabilities, right? So accelerated development, yes, 2.5 days they had that microservice ready. We provided them the code and the microservice to that team in 3 days. We were done. They have this in Artifactory ready in image, ready for production, including unit testing. Build products, not project. Because of this, when you're writing AML search, it's no more a project, right? It's not a Spring Boot project or Node.js project where you have to look at all these capabilities. It needs to be AML search only, and that's what we provide. It becomes a product, right? The application teams can now make their own products and focus on that, right? So let's talk about adoption journey. We want to talk about growth, customer use case, and contract fit.
So I will share a little bit with you guys the journey that we have. So this is a graph on the chassis consumption since the start. So we are a young team. So we are a year and a bit, right? So we started earlier last year. So chassis first beta release was rolled out in May of last year. And then look at this here is where AppFactory gets rolled out. It's January this year. And if you notice, AppFactory really accelerated adoption from our chassis products.
So you can see 20-fold growth. We had 20 to 30 services which were using chassis in production a year ago. Now the number is touching 650, and by the time we go back to Toronto, it'll be 700. I think by the time this quarter ends, it could be 1,000.
Yeah, this was taken like 2 weeks ago. So we're barely close to 600. So we ran it last week, and there were already 630-ish services using this. So there are literally around 50 services created within 2 weeks with chassis.
And that's 2,500 API endpoints, right? And this is the first year. You can imagine the exponential growth it's going to have, right?
Yeah. So one of the customers, so we have a customer which we also co-created the OAuth feature with. So their goal is to create a set of microservices to provide a single source of truth for FX pricing to be used internally so that we can achieve that omni-channel experience. So they adopted AppFactory back in January, just when we just rolled out, and they were able to deliver all the way into production in under 4 months.
Yep. And AML search, I just talked to you, 3 days, literally 3 days. And then it came 2 more change requests, one for Swagger change, one for Black Duck, couple of hours each.
Okay, so briefly touch base on the cost savings. So, there are several aspects of cost savings. The first one where you want to talk about is the capabilities. It's actually the development time saved to build these capabilities. Because we build them in a loose coupled way, every capability is a separate jar. So we're able to pull out the number of services in our Artifactory that's leveraging each capability. So with that, and we used a pretty modest estimate of
very conservative.
So of how much it's going to take the product team if they were to build these capabilities by themselves, because each project teams will have to build those. They're depending on these jars. So these are the big cost saving. So we cannot say the numbers, but you can check out the dollar size in the title.
We had the numbers slide. We were told to take that out, but let me tell you, it goes in tens of millions.
So you said the numbers.
In tens of millions. Could be in multiple tens. I'm not going to say the number, but think about it. We can easily find out how many services, 300 services are using logging, 400 services are using masking. So if it took us 2 months, right? If those teams had to build it, and if they had to build a production grade, we can easily calculate the cost savings it's doing. Now let's talk about maintenance, right? Maintenance is key. Whereas the capability building is one-time cost, maintenance is really a lot of cost, which is hidden cost, but it's a real cost. There are patches, there are bug fixes, there are upgrades all the time, right? There are enhancements. For example, I give you 2 examples. We had new auth server release for a certain use case for staff authentication. The security team said, you know what, from now on, use this auth server. And it's going to use these kind of governance policies and all that. We did that. AppFactory stays the same. Development team doesn't have to worry about it, right? We did that behind the scenes. So in the next version of chassis, they had it. Another one was the auth server person contacted us that they were getting a lot of load for token renewal, right? And that was from few services who had very low volume, but we had a very proactive logic to renew the token based on the expiry. They had set the expiry to 2 minutes for the token. So every 2 minutes, all the containers were going to this and flooding the request. And this person, so we then had JAT session in our team, and we decided we'll go lazy load on this. Again, we did that. But imagine if this was, they don't even know how many teams are using this. So if chassis wasn't there, can you imagine how many missing things will go and how much you have to multiply? They would first find out who is using this, who are low service. But we did it one time. It took us 2 weeks to do it, one developer production grid with unit test, and it was done.
Yeah. So then another point is the IT risk, the risk avoidance, right? This is the interesting thing because you could have deployed a microservice which is not production grade. It could be running all the time fine until something happens. And when that something happens, something big will happen, right?
Yep.
It could result in the outage, or loss of productivity, loss of customers, or if it could be a leakage where your customer data gets leaked out. And these are the exactly things we were trying to prevent.
Loss to shareholders, loss to your customers, sensitive data. How do you quantify this risk, right? This, when it happens, can be in millions, right? So if you are one of these microservices where the diagram I showed, they were not doing some capabilities, this is a cost which is huge, right? Last but not the least, rapid application development. If you're doing AppFactory and you're generating your code, and it generates 80 to 90% of your code within a matter of minutes and reduces your development cycle from months to a couple of weeks max, you can multiply that by number of people who are using AppFactory and generating it just in last 6 months and see what will happen next year. Again, it goes in tens of millions of dollars. So the savings are huge. It's eye-opener for executives too. They all knew it was a game changer, but now they're seeing the results. So
All right.
let's do a wrap-up. I don't think we can do how
No,
we
yeah.
operate because we don't have time.
Yep.
But we want to do a big shout-out to
Our developers.
our developers.
Yes.
We have a team of developers in Toronto. They work very hard, and they're the ones who deserve a lot of credit. So I'm just going to take their names. So Dante, Ramesh, Shubhanjan, Gaurav,
Vignesh, Vincent, Joseph, Phil, Graham. Thank you, guys. All right.
Angel, and thanks, guys.
Yeah.
And cheers. Thanks for listening to us.
Thank you.
Thank
All
you.
right. Bye.